All right, this is my first programming tutorial. Let's jump into it. When it comes to most programming languages, you have to download them, you have to download compilers, you have to set up the environment. But if you have just a browser, if you have a browser, every computer has a browser, we can open up the debugging console on that browser, and that usually gives you some tools for viewing information about the web page. But it also gives us a JavaScript console. So if you have a browser, you have access to JavaScript just on the fly. The most basic JavaScript function that you'll probably know about is called alert. I can just type alert in this, and I can get the browser to give me an alert with the message that I passed it. This is probably the most basic function you can execute. It's probably the most basic thing we're going to do in this tutorial. But yeah, that's how we can get started with JavaScript. So I'm going to start talking about types. There are various types of data in any programming language that you perform operations on. This is performing the addition operation on number types. So if I add the two numbers 1 plus 1, I get 2. That's obvious. So first and foremost, a programming language kind of acts like a calculator. 6 divided by 3, get 2. 6 minus 4, I get 2. Cool. However, there's another type of data besides a number called a string. You'll notice up here in the alert function, I passed a string that encoded several characters that spell out the word hello. So strings you can perform operations on, but they're not going to behave the same as performing those operations on numbers. For example, if I add the string of 1 to another string of 1, I'm not going to get 2. I'm going to get a string that concatenates those two characters together. There are some children who think that math behaves this way. You should probably introduce them to programming. They'll be pleasantly surprised, and so will you. There's a more complicated data type called a list or an array, in which we can actually build a collection of data. And you can do this with strings too. There will be programming languages that will not allow you to mix types in a list or an array. JavaScript is pretty flexible, so it's not going to care if we create a list with both numbers and strings in it. But be aware, some other programming languages will complain to you about that. There's another data type that's kind of called I guess I could call it a key value pair, or I could call it a key value pair list. Although you might see this referred to as a JSON object, which stands for JavaScript Object Notation. In other languages, you might see similar structures referred to as associative arrays or dictionaries or hashes. But this is similar to a list in the sense that if I want to access a value in a list, and actually, let's jump into variables. My list. So if I want to save this value and refer to it over and over again, I store it to a variable called my list. Now, if I call my list, I can get that value as many times as I like. So if I want to access one of the elements of my list, like let's say I want to access 1, 2, 3, what I have to do is use this notation and then pass 0, and that's going to give me the 0th element. And you might be a bit confused. What do you mean? If I type 1, I get the second element. That's kind of confusing, right? In programming, we always start counting from 0. So 1, 2, 3, this is the value of the 0th element of this list. And so the first is actually the second. So I'm sorry, but you have to deal with that. Now, if I take my key value pair list, let's say I store it in a value or a variable called hash. What's unique about this is I can actually use the keys that I've defined to get the values for the specific positions. So you can see this is why sometimes it's called an associative array, because you can use the key to associate the value within what is kind of like an array or a list. Now, there's another value type that I need to cover called the Boolean. Boolean is a value type that is a type that evaluates to either true or false. So every programming language has Boolean values. So true is a thing that exists. And what this is used for is making evaluations for comparing data. So if I want to say, so you saw that when I was creating variables, when I was storing variables, I might say something like my number equals 1. That means I've stored 1 in a variable called my number, so I can retrieve it over and over. But there's another important syntax called equals equals. Now, equals equals is doing a comparison. What it's doing is it's saying, is 1 equal to 1? If it is, return true. If it's not, return false. Now, 1 obviously equals 1. So we're going to get true. Let's clear our console with this button up here. But if I do something like 1 equals 2, that's obviously going to evaluate to false. And so this is very important because I might have a situation in the midst of a complicated program in which I have variable a equals, maybe it equals 1 right now. I've got variable b, maybe that equals 2 right now. And I might have a place in my program where I'm making a comparison called a comparison of variable a equals variable b. And right now it's false. But let's imagine in the midst of my program, these variables are changing. And they're not changing with respect to each other. They're changing with respect to different conditions. So in some scenarios, they'll be equal. And in other scenarios, they'll be false. So I can use a statement like this to direct program flow. So that way, in certain scenarios where they're equal, direct the program in this direction. And where they're not equal, direct the program in some other direction. So this is the importance of Booleans. So now let's move on to functions. I'm going to write a function and store it in my variable. In JavaScript, you can declare functions like this, and whatever you want, whatever functionality you want the function to encapsulate, you write within it. And so now if I call my function, this isn't going to execute that function. This is just going to refer to the existence of the function. I've saved it here, so now I can do whatever I want with it. But if I want to actually execute the function, I have to use these parentheses notation. There we go. So now you can see that I've got an alert with the message that I've written within the function. Next, we want to write a function that can take an argument. So imagine I don't want to write a specific message. I just want a function that can take any message that I want to give it later and then display it in the alert. So now what I can do is call my function, and I can pass whatever argument I want, and the function will evaluate that and pass it to the message. There we go. So now we're going to teach you how to write functions that go within other functions. This is going to be, I think, the end of it. This is going to be as complicated as it gets. And so most of what you do in programming is going to boil down to operating on lists of data, collections of data. And you're going to find that there are only so many types of functions or operations that you will end up performing on these lists of data, that you can genericize them all down to about 3 different types of functions. They're going to be filter functions, mapping functions, I'm just going to use this as a notepad right now, and reducer functions. Now, a reducer function is probably the more complicated one, so I'm going to give a very simplistic example and not really dive into it as much. But in most programming languages, though apparently JavaScript is not one of them, as you can see there, most programming languages have a function called sum that you can call on a list of numbers, and it will automatically add up all of the numbers. And this is a reducer function because the point of a reducer function is that it's going to take a list of items and return a single item that has been determined as an evaluation on all of them. And that's exactly what a sum function is doing. It's saying, take this value 1 and add 2 to it. So now I've got 3. And then add 3 to that, so now I've got 6. Now add 4 to that, so I've got 10. Now add 5 to that, so I've got 15. So in most normal programming languages, when you call sum on a list like this, it'll return 15. And that's an example, that's a simple example of a reducer function or a reduction function. But of course, we don't have it here. What's going to be a lot simpler to demonstrate will be the mapping and the filter function. Let's say I want to take the operation that I want to perform on this list is that I want to take each value in this list and I want to make a new list in which each value maps to a new value. So what I could do is I could run a function called map on this list. And what I have to do is I have to pass it another function. Oh, right, I didn't cover that notation. I have to pass it another function in which the argument is going to be the value that gets passed. And then within that function, I'm going to say what I want the new value to be. So I think I want to return a new list in which each value is the value that is passed plus 10. There we go. So map is going to take this function and it's going to execute it on each value in this list. And it's going to return a new list in which the new items in the list are the result of the function. So it's going to map 1 to 11, it's going to map 2 to 12, it's going to map 3 to 13, 4 to 14, 5 to 15. This is a good time to introduce the reduced notation for writing functions. Most newer forms of JavaScript, you're going to be able to write your function like this. You won't have to write the function keyword like you see here. And using this arrow syntax, you can, for the most part, avoid having to write braces. So you'd be able to write something like val plus 10 and encapsulate it in this function. And then guess what you can do? You can do something like my function. Val is not defined. Oh. I forgot to pass the argument. There we go. There we go. So now, this is the exact same thing as what I wrote here. I'm just using a reduced syntax. I don't need the function keyword, and I don't need these braces. So this is a nice reduced way to write functions. And this is important because what these mapping, filter, and reducer functions are is they're functions that take other functions as arguments. And so when you're doing that, you might want to write the second function on the fly. So you kind of really want to reduce notation. You can see that I assigned it to a function and then I'm able to pass my function to this function. But a lot of the times you're going to want to just write it out like this. And as you can see, this syntax is a little bit more convenient than this syntax up here. So yeah, let's clear this out. Let's try the filter function and we'll try to wrap this up. Okay, so let's see. 1, 2, 1, 3, 1, 11, 1. Basically, I'm going to write a really simple condition where I want to write a function that takes this list. So we're going to run a filter function on this list. And this filter function is going to take another function that I write in which it's going to evaluate on each item in this list and make an evaluation that will return either true or false. And then it's going to give me a new list made out of only the items that passed the condition with true. So in order to come up with a very, very simple example, I'm just going to do val equals 1. And so what this says here is that I'm taking this list and I'm filtering it down using this function, and I'm returning only the values in which this ends up being true, which of course is only the value 1. So this will return a list made out of only 1s. And I think that's about as far as I want to go. I think that's about it. And well, actually, no. Let's do something silly. So map alert val. There we go. So this is going to take each value in this list, and it's oh no, that's not going to work. No, that's not going to work. Because map really wants to return a value. This isn't going to return a value. I think it'll execute, but it's probably going to return undefined, 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 undefined. 1, 2, 3, 4, 5. Yeah, it returned undefined, undefined, undefined. The reason for that is alert doesn't actually return a value. It just does something. And so it wasn't able to map these values onto anything meaningful. So in that sense, I kind of wasted one feature of the mapping function. But let's because effectively what it's doing is it's a special kind of loop. A lot of the time for each, JavaScript doesn't have for each. JavaScript does have for each, it's just very weird.